Hi, I'm Alison Keogh, the CEO of CEEC. Our organisation helps accelerate eco-efficient minerals, and you're listening to our Spotlight Leader Conversations. Our communications lead, Ailbhe Goodbody from Montreal, speaks with Peter Flanagan, Senior Vice President at FLSmidth. Enjoy the conversation. Welcome to the CEEC Spotlight Leader Conversations. Today I'm delighted to welcome Peter Flanagan from FLSmidth. Peter's strong technical background in mining and cement technology know-how and project management for large industrial plants and projects. He's been with FLSmidth since 2007, and his current role in the company is Senior Vice President, Global Project Sales, Executive Accounts and Key Commodities. Pete, it's great to have you with us and welcome.
Thanks, Ailbhe. Happy to be here.
With COP26, there's now a keen focus by investors on net zero. What's FLSmidth doing in this area, and what are your thoughts on industry opportunities?
So thanks for that question. We at FLSmidth, we're working really hard under a overarching banner that we call MissionZero, and it's really all encompassing across our two major industries, which are cement and mining. And across all our technologies and processes, services, to reach net zero by 2030.
So the comminution is key to energy efficiency and productivity. What's the impact of new technologies in this area, and how do you think we can reduce emissions and the consumption of energy?
That in comminution and mining, we have a big responsibility to the overall mission zero of reducing power. And we're doing a lot of work in that at FLSmidth, and you know it's really all encompassing. As you know, stated earlier, we have a pit to plant focus, and that's where we want to optimize. And so, how do we spend less money and less energy breaking these rocks? And you know. Some of the obvious ways are working on crushing things further, which reduces the amount that we have to mill. And of course, that milling on its own standpoint, how can we do that more efficiently? And that comes down to different areas. You know, it can be using newer technology in mining, HGPRs, which is really, you know, new technology. It's been around for 40 years in industry and 20 years actively in mining. So we still refer to it as new technology. I would say it's a maybe newer technology, but not new. So there's a number of different areas, you know, we look at where we can bring down the amount of energy per ton of ore produced. But a lot of it, of course, is dependent on the ore. And we have different ores are going to use different machines like HGPRs. Other ones may be more suited to traditional SAG and ball mills. Maybe going back and looking what was done in the past for certain softer ores or medium type hardness ores and using, you know, ag mills, which don't have any balls in them at all. The material breaks itself. Maybe pebble mills downstream. So I think, you know, it's an exciting space to be in, because depending on the specific ore, there could be different solutions that certainly dramatically reduce some of the power and energy that we need to put into getting this job done of breaking rocks, to then further take that powder that comes out of this and float it. And then on the other hand, too, with coarse particle flotation, that means that we can float bigger stuff. So we need to grind less rocks. We'll grind the rocks less further. So if we don't have to put as much energy into breaking them up to float the same amount of material, copper, whatever metal we're trying to float there, that's also a big win. So it's sort of looking at the whole flow sheet. Can we do more work upstream? Can we do better work downstream so we don't have to break it? And then if we do have to break these rocks, can we do more upstream and crushing? And when we finally get to grinding it up, what machines and what processes are most applicable, and it's probably different between different ore bodies.
So looking at mining and processing as a whole, what are you the most excited about in this area? For example, advances, innovations, and new options for industry.
So there's a lot, again, getting back to that flow sheet, one in the pit. And again, it's not new, but it's certainly not implemented everywhere we think it should be, and that's in-pit crushing and conveying. And that's the ability to really get rid of trucks that haul all this ore and all this waste rock up out of the pits and over to the process plant where we need to concentrate it or refine it or beneficiate it. And now by using conveyors and putting the crusher down in the pit, I can do that without any trucks at all, maybe a few short ones to take the short runs. And now I have the ability to really power the whole pit electrically, as opposed to, most truck operations are still require diesel, and many of them still require drivers, and I can get rid of all that. So in-plant crushing and conveying is a real exciting area. Another area that's really exciting is at the other end of the flow sheet, the tailings area. And now we're working hard and have some good smaller references on dry stack tailings, where instead of the tailings going out to a big wet pond that can be a future liability, we can actually recover all the water back into the process, 95, 96% of the water, and take that residue, the leftover tailings, and actually stack it dry in layers, going up and building another hill that we can plant grass on and make it green.
So what do you think is the future of mineral processing? So in the immediate future, by 2030 and by 2050?
Yeah, there's a lot of different things we're working on, and there's a lot of different opportunities. And does that come with pre-concentration? Right now, we dig up this rock in the pit, and we kind of make one decision: does it have enough metal in it for us to put it into the process plant, or not? And if it's not, it goes to waste rock, and if it is, it goes over to the process plant. Well, maybe there's some ways, and obviously some of that stuff that we decide to process in the plant certainly is maybe not exactly what we do want to process in the plant. So how can we use sensors and digital devices to look at that rock as it starts going through the process? And maybe after crushing, maybe we find out a certain percent of it is too low grade. We're able to sense that. Maybe we can take that out. We will call that pre-concentration. Maybe once it gets crushed, we invest in milling it, but we're about to get to the flotation, and we realize that there's a way to sense, again, with digital, that some of this ore probably isn't worth going through the rest of the process. So can we take it out at that part in the process? So I think a lot of these, there used to be unit processes may make decisions on, do we continue to make the processing investment in that ore to take it all the way through, or now it's just on or off? And again, coarse particle flotation fits into that. And then a lot of these ones, if we do take it out early, then it's easier to process for dry tails. It may not even have been made wet yet. So, that's an interesting area from a flow sheet perspective. And then the vertical roller mill is an interesting technology that's been used in cement, well proven for many years. It has some interesting attributes, and I think there's going to be a place for that certainly in the comminution flow sheet with certain ores of the future.
What's your vision for potential opportunities in the future of industry?
Again, I think this focus on, a lot of us that worked through the last cycle, it was all about tons. And how many tons can I get out of the mine? How many tons can I get through the process plant? And that was always talked about first. And obviously, tons matter. That's an efficiency scale and everything else. But I think now, it's pretty exciting to hear everybody engage in discussions. Okay, how can I do tons, but how can I also do tons with less impact on the environment, with less energy, certainly with, less life cycle costs, long-term costs. So I think, it's pretty exciting to be looking at this whole thing holistically in mining. And what is the total cost of ownership? What really is the life cycle cost? What is the environmental cost? What is the environmental footprint? What is the water per ton? What is the energy per ton? Some of the, the benchmarking that CEEC's doing right now fits in really well with that.
So you have a worldwide view of mineral processing plants. Would you be able to share some inspiring examples of FLSmidth installations that are beginning to substantially save energy, emissions, and/or water, and what the size of that impact is?
Yeah, they go from big to little. We have this little device that goes on a sag mill and listens for where the load of balls in the sag mill are hitting. Obviously, you want these balls to hit the material you want to break, not the liners or things on the other side. It's a small device, and it has algorithms in a box that adjust the speed of the mill, and a camera that looks at the material coming into the mill to see what that looks like and put that together. And we've been putting these things on some mills and seeing paybacks for the whole system that's measured in in a matter of days or weeks, not even months.
So what breakthrough innovations could dramatically reduce mining's footprint in future, and what's needed from the industry to invest for success? For example, eco-tails, dry separation, or step change options?
Yeah, I think we just need to make a commitment to do it. And we did a lot of work at FLSmidth with eco-tails, partnering very close with a major miner. And it was a great journey. It was a 3-4 year journey. We're looking for other partnerships as FLSmidth with miners and other stakeholders, industry. We already have a lot of collaborations around the world with different universities. And we need to all come together and say, we're going to do this, and this is do the homework. This is the right solution.
So the energy transition demands unprecedented change and more metals. What can we all learn from past innovation successes to help industry speed the pace to reduce mining's footprint and improve ESG?
Well, again, I think, it's true. The reality is the world's going to need a lot of copper to get the power from where the wind blows and where the sun shines to where the people need it. And electric cars use, I don't know, something of 3.5-4 times as much copper as IC, internal combustion engine cars. And obviously with these new batteries, we're going to need a lot of nickel and a lot of lithium. So there's no way to transition to this green economy without increasing the amount of metals that we pull out of the ground. So, of course, the question is, how do we do that with the minimum impact? And, we talk about low carbon, and that gets a lot of the press, most of the press, it seems, generally. But, in mining, I think it's also important to us to be low impact, so low water usage. Low impact overall, and how do we do that? And overall, that's really what the MissionZero stands for. It's not just zero carbon, it's zero impact, zero water waste, zero energy. And so I think these are something that we're going to really need to work hard on. We want to transition the world to low carbon, and we need all these metals. We got to get them. We got to get them out, and we got to figure out a way to do it, minimizing all that impact. And we're working hard on it at FLSmidth.
So, Pete, thanks so much for your great insights today. It's wonderful to hear of the work that you're doing. It's really interesting stuff.
Yeah, I appreciate the questions. It's an exciting time to be in the mining industry, Ailbhe. Thanks very much.
Thank you.
If you've enjoyed today's conversation, get in contact Contribute your work and join CEEC's followers. You can tap into free articles, join our events online or in person, and watch and share future podcasts, videos, and webinars. A big thanks to our valued sponsors and visionary volunteers, including our guests who we're interviewing, who make our work, our not-for-profit work, possible to help accelerate eco-efficient minerals. Thank you.